Okay, here's just a quick review of algebra review. Just a quick reminder. The first part is multiplication, and we are simply just going to multiply terms together. The first one is just a common term on the outside. We multiply it with the front, multiply the back, and 3 times 2, of course, is 6. X times x is x squared. 3x times 7 is negative 21x. Don't lose that x. Don't put an equal sign anywhere and say x is equal to some number here, because there's no equal sign. All we ask you to do is multiply, not solve. Okay. Number 2 here, don't just multiply the front and multiply the back. This is normally referred to as FOIL, first, outside, inside, last, or the box method, as some of you would know. But ultimately, you're going to multiply 4 terms together. 3x times x is 3x squared. 24x, this is negative 4x, and this is negative 32. You take it outside the box. If you learned it, the box method, in previous algebra classes, the 2 in the middle can be combined, and that should be positive 20x minus 32. Okay, after multiplication, we do the reverse of multiplication with factor, like 7 through 9 or even 10 through 12 where it says to factor. This is essentially these guys in reverse. These guys here, 7 through 9, where we look for common factors, our answer will look like something like this up above, where it's a term on the outside times parentheses, like it's a term times a parentheses. So when you go one way, it's multiplication. When you go the other way, it is called factoring. This should end up being some term times a parentheses when we look for a common factor. What can you divide from 4 and also 18 is what you're basically asking. What number can I divide from 4 and also 18? And that number is a 2. So what we're going to do is put the 2 on the outside, and we're forming the answer. Then you think 2 times what will give me the front? 2 times back will give me this negative 18. Well, 2 times what will give me 4x? That is 2 and an x, minus 2 times what will give me 18? That's a 9. And then this is it. That's called factoring, where I split it into the multiplication of 2 terms. All right, we're going to move down to number 10 here, where it asks us to factor again. And this one is the absolute reverse. Where you see a 3 term, it's going to be the absolute reverse of number 4, where they ask us to multiply. When we're done, we should look like parentheses times parentheses. So this is the one where we go parentheses, parentheses. These 2 numbers in front will give me x squared. Well, that's x and x. Then you look for numbers that multiply to 12 and, multiply to 20, add up to 12. So what 2 numbers multiply to 20, add up to 12? And you think of 5 and 4 and 1 and 20. But the correct answer looks like it's going to be 10 times 2 is 20. 10 plus 2 is 12. And that will be our answer. This again is factoring, where I split it into the multiplication of 2 terms. This is called a binomial term times a binomial term. This is called a single term times a binomial, but it's splitting it into the multiplication of parts. Number 13 here, we're actually going to solve. This is pretty much the same exact question here. This is x squared as number 10, x squared plus 12x plus 20. This is x squared plus 12x plus 20, but now there's an equal sign. And so you're actually going to solve for x. The way you're going to do this is called the zero product property. It's already equal to 0, which is good. Product means multiply. And so essentially we want to factor this like we had been doing in the previous problems. X, 2 numbers that multiply 20, add up to 12. That is 10 and 2. And if the equal sign wasn't here, we'd be done with factoring, but it is here. So then you must go, this number here in parentheses is equal to 0, or this side is equal to 0. So there's going to be 2 answers. One, after you minus 10, the answer is going to be negative 10. 1, if you minus 2, the answer is going to be negative 2. These are the 2 numbers. If I plug them back into the original problem, like a negative 10 or a negative 2 here and here, do all the number crunching, you will get 0. Okay, I'm going to actually jump to number 20. We are simplifying a radical. We actually see a multiplication here, when you multiply or divide, it is okay to multiply or divide. This looks like a division, but it is, a fraction, but it is a division bar. This is multiplication. Now when you multiply, don't go 15 times 2. You can only do outside numbers outside the radical with outside. So there's really nothing here except a 1. So 1 times 2 is 2. And 15 times 6, inside number with inside number, that's 90. Okay? From there, we are going to break down the 90. We don't really touch the 2 because 2 is a good number. We don't need to deal with that. This is 9 times 10. We can break down, again, I'm leaving the 2 on the outside. We can break down the 9 as 3 and 3, and we can break down the 10 as 5 times 2. This is still all underneath equal to 90, so I haven't really changed any numbers yet. Anytime you double up, that represents a perfect square. That number goes to the outside. Anybody who's single just goes back to 10 here. These two numbers multiply to 6 radical 10. This is called simplifying the radical. Okay? When you multiply inside with inside, outside with outside. So for this one here, you can divide inside with inside. All right, we're going to jump ahead to 22 here. This is rationalizing the denominator, which basically means we don't want the square root sign on the bottom part of a fraction. Okay, we just need to get rid of that guy there. There is a process. First of all, you cannot divide a regular number, with 5 on the inside. But what you're going to do is take that fraction. I don't want that radical sign. What we're going to do is multiply the top and bottom by that same number. So 5 over 5. Now, when you multiply the tops, you multiply the bottoms. When you look at the top, there's a 5, regular number 5, and a 5 on the inside. You can't multiply outside with inside, but you can shove them together. And that's what we're going to do, which basically means 5 times radical 5. Inside, inside. Now you can multiply inside with inside, and that's 25. The square root of 25 is a perfect square. What number times itself is 25? It is the regular number 5. Now this 5 is going to cancel out with the other regular number. Don't cancel it out with this. This really is not a 5. This is, if we go to a calculator, the square root of 5 is, it's like 2 point something. But you can cancel that out, and this is the answer for 22. And the final review we're going to do is systems of equations. This is where you have 2 equations and 2 variables like x and y, x and y. We have to solve for both x and y now. Don't just stop after you solve for y or after you solve for x. We have the luxury for this first one. Notice this first part where it says x is equal to all this stuff. X is by itself. We're going to do the substitution pattern. Hopefully you remember this. You take what x is equal to and just replace it into the other equation. Substitute. So instead of x plus 2y, it's now going to be 7 minus 3y. Then we're going to go plus 2y is equal to 4. Okay, and then we just do the algebra. Notice all we have is y now, and we can just solve this. Negative 3 plus 2, that's negative 1. And then I'll minus this 7 over here. You got to be real careful with the negatives now. 4 minus the bigger number 7 dips into the negative 3. Divide by negative 1. Looks like my answer here is negative times negative is positive 3. Be real careful with your positive negatives. A lot of people make a mistake of going, okay, I'm done. No, there were 2 variables. There's an x and there's a y. So what we're going to do is take either the top or the bottom. It doesn't really matter. I'm just pick the top one here. You take either equation, and I now know what y is. I'm going to put it right there, which basically means substitute. And we're going to solve for x. So x is equal to 7 minus 3 times whatever this is, 3. X is equal to 7 minus 9, negative 2. 7 minus the bigger number is negative 2. So those are the 2 numbers. If I plug them in the top equation and the same 2 numbers in the bottom equation, both things will be equal.